This is going to be our density current review. So listen up. Okay, first of all, what is a current? A current is a body of water that flows through the ocean, sort of like a river. And the thing that we've talked about would be the Gulf Stream and the North Atlantic Current. So if all this down here is the ocean, our current would actually flow through it and circulate around it like we've talked about, okay? What are the two types of currents? Well, so far we've learned about surface currents. Surface currents are caused by the wind, and they generally carry warmer water to make cold climates warmer, and they can also help cool off really hot climates like near the desert. Okay, so surface currents are caused by the wind, and they can have the direction changed by the Coriolis effect, okay, and by continental deflection, by bouncing off the continents. So surface currents is one type. The second type of current, and the new one that we're talking about now, is the density current. Density or deep currents. Now, as the name indicates, these currents are deep in the water. Surface currents are up on top of the water, but deep or density currents are down deeper into the ocean. To help us understand where density currents come from or how they're caused, we need to make a few comparisons. Okay, for example, if we compare fresh water to salt water and warm water to cold water, well, fresh water is less dense than salt water because the salt in the salt water makes it denser. More salt, greater density. Cold water is more dense than warm water. The molecules that make up cold water are more tightly packed together, making cold water more dense. Warm water will float on top of cold water. Denser is heavier. Denser is heavier. Remember we did the activity where we put the different kinds of water together, how the cold, salty water would sink to the very bottom, and how the warm water would float on top. Okay, so what two things can move or cause currents? As we already know, the wind causes surface currents because it pushes them along. It pushes this water through the ocean. But a difference in density causes density or deep currents. Don't forget, density currents and deep currents is the same thing because deep actually describes a density current goes deeper in the ocean. Remember, density affects the weight or mass. The greater the density, the heavier the mass. The deeper it's going to sink. Okay, we've already kind of talked about this, but what causes a density or deep current? A difference in density. This difference in density can be caused by a difference in salinity or temperature. Salinity means saltiness. The saltier, the denser, and the colder, the denser. So a density current is caused by a difference in density. When water evaporates, what happens? Well, when we studied the water cycle, we learned that only the water evaporates and the salt gets left behind. So the fact that salt gets left behind means the water that's left that hasn't evaporated yet, now it's going to be extra salty. So the saltier, the denser. The more salt, the more dense. Near the equator, what can cause a density current? Okay, we think at the equator, we know the water is really, really warm. And as we said earlier, warm water is less dense than cold water. However, lots of heat causes lots of evaporation. Lots of evaporation means lots of salt left behind. More salt means greater density. So even though the equator is warm, really, really warm water, it's causing so much evaporation that as this water evaporates, it leaves behind that extra salt. Then extra salt makes that top layer of water be more dense, so it begins to sink. And then as that water sinks, then we've got more evaporation and more salt and denser water, so you have a continually repeating process of evaporation, extra salt, density, sinking, evaporation, extra salt, density, and sinking. We just talked about how evaporation at the equator can cause a density current. But let's go up to the North and South Pole. Okay, when seawater freezes, How does this cause a density current? As seawater freezes, the salt is forced out of the ice, and because ice floats, this makes the water under the ice extra salty. As we know, cold water is already denser than warm water, but now when we add the extra salt, it makes it even denser. So we have a lot more powerful density currents near the Arctic, near the North and South Pole probably than we would the equator, because this water is very, very cold and very, very salty, making it a very powerful density current. Okay, here's a big one. What is the thermohaline circulation or global conveyor belt? And why do I care? Thermo means temperature, and haline refers to salinity. The thermohaline circulation is a huge density current that circulates throughout the world ocean and affects the global climate. We call it the global conveyor belt because it acts like a giant conveyor belt and conveys warm and cold water around the world, which affects the Earth's climates. So thermohaline means temperature and saltiness, and this, as we've seen on some videos, this thing tends to take up to 1,000 years or longer to circulate completely around the world, but it moves warm water and cold water to different parts of the world, which moderates our climate. It's very, very important. What makes a gyre different from a density current? Well, as we know, a gyre is a surface current that's driven by the wind, even though what makes it a gyre is the fact that it's driven in a circle. It spins in a circular direction throughout the various oceans. But it is a surface current driven by the wind, and a density current is a deep current caused by differences in density. These differences in density can be caused by temperature or by salinity. Anything that makes the water more dense is going to cause it to sink, and as it sinks, it's going to cause a current. What are prevailing winds? Prevailing winds are winds that continuously blow in a certain direction. They never stop blowing. Two examples are the trade winds and the westerlies. The trade winds blow along the equator from the east towards the west, and the westerlies blow from the west. Remember, we said earlier that the winds are generally named for the direction that they come from. So if they're the westerly winds, they're coming from the west. But prevailing means they never stop blowing. They're constant. Well, here we have a map showing the thermohaline circulation. As we look at this, we can see that it's a huge, basically one giant current that hugs the bottom of the ocean. It does have some warmer water areas, but for the most part it's really, really cold water. But this is deep water. This is a density current. Now, we do have, don't confuse that with our surface currents, our gyres. See, they're completely different. This is the Gulf Stream North Atlantic current over here. Okay? All right. And so we know that we have opposite direction, so gyres. This is a gyre. This is a gyre. Remember, it brings down cold water from Alaska, brings down, circulates around Hawaii, and this is a gyre out in the Pacific Ocean. So these are surface currents, but this is the density current. This is the thermohaline circulation, which travels entirely around the world, and according to what it says, it could take up to 1,000 years to make this entire trip. Thermohaline circulation has an influence on the entire climate of our planet.